Hi guys, welcome back to another episode on our A2 chapter 26, Rate Kinetics. So in this chapter, we're going to cover there's a few elements that is very crucial in this chapter. For example, you have to know how to identify the rate order, the order of reaction, and to understand what is the meaning of first order, zero order, second order. Then second thing is how do you construct your rate equation. That also know the difference between the half-life in knowing the difference between the half-life in first order reaction, zero order, and second order reaction. And also you must know how to construct your rate equation, so to identify your rate determining step. So identifying your rate determining step is quite difficult, so especially when questions come up with like a different ions. Okay, so in the lesson, I've went through some example with you guys, so please go through it. At the same time, you need to know the mode of action of catalyst. Like a homogeneous catalyst, you don't need to know, but you need to know for heterogeneous catalysis, the mode of action. That is very important. Okay, and apart from it, Arrhenius equation is usually in paper 5, so it's not very important in your paper 4, but you still need to know how to attempt questions like that. And also the last one, you need to know how to construct your rate mechanism involving either an ions or involving a catalyst. Okay, and that's it. So without further ado, so please go through the entire recording. So please go through the entire video and try your best to do some topical questions here. And all the best, guys. Hi guys, let's continue here, shall we? Okay, so guys, you see, right, last week done first order, second order, zero order. How do you determine the rate order for a reaction? Remember, yeah, guys, for a rate order, right, we can only find it from experiment. Yeah. Okay, so for the rate order, right, we can only identify the value from experiment. All right, guys, now what do we have next? We have order of reaction. So, guys, first you need to know the definition. We call it as the power. Okay, I want you guys to write it down. Okay, so power in which, okay, the concentration of the reactant is raised. Okay, the concentration of reactant is raised. Okay, in the rate equation, that's it. So some of you guys having P5 tomorrow, right? Good job, good luck. Yeah, I mean, we have done enough P5 already. Hopefully I got, hopefully you're able to do some of the P5. Okay, so guys, highlight this part, power in which power concentration is raised. That's it. By the way, this type of question come out in your P5 also. So your P5, right, they might give you a graph, then they will ask you to identify, is it a zero order, first order, second order? Okay, that you need to know it. Okay, so it can be determined experimentally, not through a balanced chemical equation. Remember, okay, determine experimentally. So we can only get it from experiment. So what are the way that we can identify your rate? So we can plot the rate of versus time. Okay, so the first way to find out rate of reaction versus time. The second one, right, concentration of a reactant versus time. Okay, so two ways we can identify the order of reaction, rate of reaction versus time, concentration of reactant versus time. That's it. Okay, two methods only. And guys, we can also deduce the successive half-life from the graph of the concentration against time. Okay, now let's look at the half-life and reaction. Alright, guys, by the way, you see, right? Okay, this graph, right, is drawn with your concentration of reactant versus time. Time is so likely again. Okay, so time is in minute. Okay, guys, now what is half-life? I mean, you guys done physics. Okay, you should know what half-life is, right? It's basically the time taken for the original value to be half, right? Am I right? Good. So guys, we put it as half-life, right? Is the time. Okay, so the time taken for the concentration of the reactant, okay, to fall to half of its original value. Okay, so half-life is always time, yeah, taken for to half of its original value. Alright, guys, now let's look at the graph. I want you guys to identify the half-life for me. So, guys, how to get the half-life? You see, initial concentration is 4. Okay, drop to 2. Okay, how long is it? 70 minutes, right? Okay, then what about from 2 minutes? Around 17.3. And what about 1 minute? Drop to 0.5, 16.7, right? Okay, so guys, that's how you identify your half-life, yeah? Okay, so you see that, right? The half-life is almost constant. So I can say that the half-life is almost constant, right? Okay, it's approximately around 17 minutes, right? All right, guys, next. Okay, let's say, right, if your half-life is constant, okay, how can you identify or how can you calculate your half-life? Okay, so I can say that, right, half-life, okay, I'll put it as T half, yeah, is equals to ln 2 divided by, highlight this equation, half-life equals to ln 2 over K. And if you were to apply this formula, right, this is only valid for first order, yeah, remember. Okay, only valid for first order reaction. Please, okay. This equation, right, is only valid if it's a first order. If it's not a first, you cannot apply it yet. Because if it's not a first order, your half-life always changes. Okay. Okay, guys, next. What is K? It's basically our rate constant. Then all right, guys, now, okay, so the successive half-life will have a value of around 17 minutes for the reaction. So I can say that, right, this reaction is first order because the half-life is almost constant. Highlight half-life almost constant, highlight first order. Remember, for a first order, the half-life will be constant. If it's zero order or second order, half-life always changes, yeah. That's it. Okay, now it's going for P5 tomorrow. So you might need to know how to plot this type of graph and to identify your rate order. Okay, so this is in your P5. Yeah? Okay, so sometimes it might come out that has to plot the graph, has you to identify whether is it a zero order, first order, second order. All right, guys, now let's revise a bit in. What is zero order? So, guys, zero order, right, which means if concentration of the doubles, what will happen to the rate? The rate will stay the same, right? What about second order, first order? Concentration doubles? Rate doubles, right? Is directly proportional, correct? What about second order? Concentration of A double, 4 times, right? Okay, so this will be a power graph, right? Okay, guys, now let's look at the graph. Yeah, guys, try to understand the graph instead of memorizing the shape because memorizing the shape does not work. Okay, so because sometimes they might twist and turn. Okay, they might give you some random graph. You need to know how to plot it. So, guys, you see this on your y-axis, that's our rate of reaction. On our x-axis, that's our concentration of reactant. Okay, guys, look at it, yeah. Okay, I want you guys to look at this black color line first. Let's look at the black line. So, guys, you see, right, as concentration from 1 go to 2, what will happen to the rate? The rate, for example, this 10. Let's say from 2, concentration of 4 mole per dm2, still staying the same, right? You see that no matter how much you try to multiply the concentration, the rate will always be the same, right? So this will be a zero order, right? Hold on. So guys, put it down. This is a zero order. So for a zero order, right, it's always a straight line. No matter how much you try to multiply the concentration, okay, the rate doesn't change. That's it, zero order. Let's okay, you see, right? For this line, okay, you see, concentration rate is what? Concentration is 2, rate is 2. Concentration 3, 3. Concentration 4, rate 4. So instead, when you double up the concentration, but also doubles, right? So this will be a first order. So guys, remember, first order is always a linear line, yeah? Okay, and finally, guys, do you see a power graph? Of y equals to 2 to the power of x, right? Okay, y equals to 2x. That's it. So this is a second order. Okay, understand? Okay, guys, that's how we identify the order from a concentration versus rate of reaction graph. Yeah. Okay, last say, guys, look at this, right? Look at this. This is the concentration of reactant versus time graph. Okay, so first type of is when I have the concentration of reactant decreases steadily. Okay, so decreases steadily. What do you call this as? So guys, let's look at it. Yeah. So remember, in the concentration versus time graph, how do you identify your rate of reaction? How to find reaction? The gradient, right? Am I right? Correct. So guys, for what is the gradient? The gradient is constant, right? Am I right? Which means no matter how much the concentration of reactant is changing, your rate is constant, your rate is constant, right? Am I right? So which means that this is definitely our zero order. As I try to understand the graph, guys, don't memorize the shape. The shape doesn't work. Do not memorize the shape, but understand the shape. Okay, to memorize it. So in this graph, remember, yeah, your gradient is our rate of reaction. Am I right? Okay, guys, I mean, zero order is very easy to identify. Zero order is so easy to identify. So, guys, now we have two lines. Crazy. So, these two lines, right? Okay, one of it is a second order, another first order. So, how do you identify, right? You see? Okay, so identify the key trick, especially in your P5. I mean, some guys have done it already. So, to identify or to differentiate a first or a second order. Okay, guys, how do you differentiate the first and second order? You always look at the half. Understand? Look at half-life here. All right, guys, if the half-life is constant, it's a first. Again, guys, if the half-life never change, that's a first order. However, if the half-life, okay, that's a second order. Okay, so guys, how we differentiate a first and a second order? Zero order is easy, straight line. First and second order will always be a curve. So you have to differentiate the half-life. Okay, the half-life, if the half-life is constant, first order, not constant, second order. Understand? Good. So guys, this will be a first order. Okay, I just give you the answer first. This will be a second order. Okay, later I will show you some example. I think I have another example that I want you guys to go through. Give me a minute. Let me scroll through some questions. I want you guys to draw some graph. It's the last time. It's the last time. Time. Okay. Concentration. Because you know how to talk already. It's okay, it's fine. Guys, let's move on to the next part. Versus rate of reaction. Time was so good. Never mind. Okay, guys, now let's look at next page. It's okay, later we're gonna do some questions together. Okay, so we will. Alright, guys, look at zero order, first order, and second order. Guys, again, zero order for a time versus concentration versus time graph, right? It's easiest, am I right? So by the way, concentration versus time graph, my gradient is great, right? Okay, so first one is pretty easy. Okay, if you look at it, right, my gradient is constant. Constant means it's a zero order. Am I right? Constant rate, right? So a constant rate, that's a zero order. At the same time, guys, if you look at the half-life, okay, the half-life, right, will get smaller and smaller, yeah. So another determining factor, right, is that you have a decrease. Okay, so the half-life will get smaller and smaller. All right, guys, next. What about first order? As what I mentioned, right, for first order, okay, so first order, remember this, it's always a constant half-life, right? You can see that the half-life here are the same. Okay, so you have a constant half-life. Okay, so remember a keyword constant half-life. Okay, and it's independent of the concentration of the reaction. Then use the formula half-life is equals to ln 2 over K. Okay, that is the only, sorry. This formula, right, is only applicable for first order, yeah. Do not use formula for second order. Well, guys, if you look at the second order, your second order, right, you get increasing half-life. You can see that your half-life is getting bigger and bigger and bigger. So you get increasing half-life. That's it. All right, what's that next? All right, guys, let's look at page 14. Oh my God, this is your time to BS. Oh my God, this is the book. This is the best part. Give me a minute, yeah. All right, guys, now we have kinetics and reaction mechanism. Oh, best. This time, right? Okay, this is your only chance to BS in your exam. Okay, basically, right, whatever that you're gonna, okay, so you can BS anything, everything. Okay, so again, your answer and my answer and the answer might not be the same. So we have a guideline to check your answer, but okay, so our answer might not be the, it's your time to BS. Okay, so if you are very good in BS, that is your favorite. Okay, your favorite part, you can need BS in this part. Okay, you can basically write anything you like. So guys, now let's look at kinetics and reaction mechanism. Okay, first, you see, right, reaction, first you have to understand that, okay, our chemical reaction, right? Wait, can you go up? Go up. Okay, so again, your chemical reaction, right, doesn't happen in just a single step. So basically, when the chemical reaction is happening, right, it's always multiple steps. Okay, so what you look for your reactant and product. Okay, that is before. Okay, this is so basically, this is like when you guys are still single. This is like me after married. Between how many ex you dated, right? Okay. So basically, we don't talk about it. The same thing here. So we don't talk about the ex. But right now, the mechanism, right, is you gonna talk about all the exes. Oh, I have this shitty relationship with toxic ex. My ex cheated. This is when you BS in your mechanism. So you have to tell me how to react, and it can be any way you like. So, but what I want to see is, let's say you girlfriend, then just want to see you guys are married. That's it. Okay, so in between, right, you can just type you want. Okay, so this my girlfriend dated another guy, then I dated another, then I dated his friend, all that. But that's it. That's the story. What you have friends like that. Complicated relationship. Yeah. All right, so guys, now you see, right? This is what we are looking at. Okay, so and the girlfriend. Okay, finally you guys, I'll be celebrating. Okay, then now let's break it down. Like throughout your dating life, what happened exactly? Guys, you see, in exam, right? So what they might ask you to do here, okay, is to propose a mechanism. Okay, guys, the moment you see the word propose a mechanism, okay, answer can be literally anything. Okay, so propose mechanism. Okay, what else? They might ask you to identify a rate determining step. This is okay, determining step. Okay, so in exam, they might ask you, hey, identify my rate determining step. So guys, how to check, right, whether your answer is correct or wrong? Okay, so after combining, right, so first, your answer, right, must match the original rate equation. Later, I'll talk about it. Okay, remember, must match the original rate equation. Must. Guys, after combining your equation, okay, you obtain an original equation. Okay, so basically in the exam, they might ask you to propose mechanism. Okay, second, identify a rate determining step. Okay, your answer, right, must match original equation. Get the original chemical equation. All right, guys, now let me show you how to do it. All right, guys, you see, right? This is before. You see, before, this is after. Okay, so now, right, I want you guys to propose a two-step mechanism. Okay, let's propose a two-step. I just want a two-step first. Okay, we're gonna go from easy first. Usually in exam, right, they always ask for two-step, or sometimes three-step. So I don't see more than three. Okay, so guys, let's look at first step. Guys, you see, right? This is Colleen. Um, any girl from your school that I know, bro. Uh, I should know somebody. I know you're junior. I know you're junior. You know this girl always texts me. Who's that? Wait, I get you the full name. The junior. Sorry? Yeah. Oh yeah, you're junior, right? Okay. This is also from your school, right? Abigail, is she from your school? From your school, right? Yeah, bro, this fella every time text me. You know the junior what they ask me, sure. How are SP hybridized orbital? What is SP3? What is SP2? Say, oh my god, spamming me crazy. Spamming me some YouTube videos. Oh, interesting, your junior. Alright, so you see, right? Okay, let's say we have these two fella dating and eventually marrying. Okay, just imagine that. Okay. So guys, first step. Okay, so I'm just gonna take one of the reactant NO2, right? And I can react with F2. Okay, so this is how they met. So guys, okay, what do you do? Can be anything. Please tell me. You have to BS. You guys just tell me what you guys want. Anything also can. Yeah. Anything, really, literally anything. Okay, you have a guideline here. Up to you. NO, no. Then, then what else you want? NF, I cannot. N already used. So what else is left? You have one O and one F2. Oh, F2. FO looks very wrong. FO2 looks very. Okay, again, although you can BS, but try to BS a proper compound. No, FO, then plus F. A bit can, but it's wrong. It's a bit wrong. So, guys, okay, come, is it? Yeah, I want it to be. Yeah. Okay, can I end over? Okay, let's see if can we O2. You guys like FO2, right? Oh, F2. F2O. Okay, F2. Yeah, so basically, again, is you can BS. Okay, so guys, seems wrong, right? Let's correct the answer and make it right. Okay, so again, there's no absolute right. Okay, so this is just a mechanism that you propose. So basically, right, you see this guy, this girl, okay, then boom. So somewhere, okay, you have these two random fella come out. So guys, you see, right? Okay, now let's look at this random fella. Is this random fella appearing in product? No. This random fella is not appearing in the product, which means these are your X that you have to get rid of it. You have to hide it away, be like, brush it under the table. No, you cannot see. Don't. Okay, so basically, you have to get rid of these two. So that we call it as an intermediate species. So again, right, what is an intermediate species? Is species that present in the mechanism, but when you combine it, right, will not be shown in the overall equation. Okay, so I can go second step. So now, right, your X and another X. All right, guys, let's look at the reactant. Yeah, what else we have from the reactant? I already used up F2. Am I right? I used up one NO2. So how many NO2 left? One. So I have to add one here. Okay, so guys, now you cannot BS anymore. Okay, so now you have to be serious already. Oh, cannot BS anymore. In step, I'm the answer. So how many N you have? 1, 2, right? So I can say that everything will come into 2 and no 2F. Yeah, you just PS. So guys, yeah, 2 and 2F. Okay, so let's say, right, if I try to add them up, you see, how do I know whether my answers are wrong? If you up, do you see that my intermediate species will get cancer? NO get cancer. What else? F2O, F2O get cancer. And guys, if you try to add them up, what it will be? 2NO2 plus F2, 2NO2F. See that? Alright, so guys, my answer does make sense. Okay, so that's how you know, my mechanism is okay. So funny, right? Again, you can basically BS anything. Anything. Or later I will show you hard question. You guys, yeah, hard question together. Right, guys, let's say, right, if this is your mechanism, our intermediate species, right, is NO and F. F2O. F2O. Is F2O actually a thing? I don't think so. Yes, correct. You can come up with imagination. I'm not kidding. Really, it can be. I'm not kidding. Yeah, it is. It is actually a thing. F2 is actually a thing. Yeah, F2 is actually a thing. Yeah, I mean, yeah. Again, it can be anything. Guys. Again, it can be anything. Okay, if you want to be, if this can go on 3 step, 4 step, because right, guys, you see, you can do it like that. You can do it like then one F free radical, another free radical, then one O free radical. Then you go second step, you can go third step, you can go fourth step. Guys, really, it can be anything. You can just throw it as long as you can explain it. How will you check? Intermediate must cross out. Okay, when you add them up, it's the same, then it's correct already. And in between, yeah, do your BS. Yeah, that's it. Okay, so that's the only part that you can BS. Yes, imagination, which is why your answer and my answer might not be the same. Doesn't mean that you're wrong. So you just have to check to see whether it's right or wrong. All right, guys. Now it's quite easy. Let me introduce you one more, which is rate determining step. All right, guys. Rate determining step, we always call it as RDS. Okay, so my short term RDS. So guys, what is rate determining step, right? We call it as slower state, so slower step. Okay, the slower step in the rate equation, slower step. Remember the okay, so rate determining step is the slower step. Okay, so guys, you just imagine, right? Okay, a reaction is just like you go for 4 times 100. Okay, so how do you determine whether you win or not, right? You must look at the slowest person in your team. Okay, the slowest person, if you have a very fat fella, right, in your 4 times 100, right? Basically, no matter how fast you run, right, as long as the slow fella is you 100% lose the same thing. Okay, so rate determining step, right, is basically the fat fella that run the super slowest. Okay, we don't really care. For example, right, let's say in first and second step, right? Okay, and this is my slowest. Okay, this is my rate determining step, which means no matter how fast a reaction is happening, it's useless. Okay, for example, this reaction has 0.5 seconds, but this reaction gonna take 3 minutes. So at the end of the day, your overall rate of reaction is still 3 minutes, right? Okay, understand? Okay, so we always look at the slowest step in in mechanism to identify which is the determined step. Guys, in order for you to identify your rate determining step, right, you have to look at your rate equation. Okay, so highlight this rate equation. So please, how do you identify your rate determining step, right? Which means my rate equation, this rate equation, okay, always determine, okay, our rate determining step. I just put it as RDS. So the rate equation, right, would what is in S? Okay, so guys, RDS. Okay, so basically, all right, what do we have? Okay, we ICL 1, H also to the power of 1, right? So basically, right, I must have 1 mole of ICL, mole of I2, AH2. Must have. So my rate determining step must have 1 mole ICL, 1 mole H2. Okay, because it's stated here. My slowest step must have 1 ICL and 1H2. Okay, so guys, now, okay, I'm going to give you a task. Okay, I want you guys to propose a two-step mechanism. Okay, I will give you the steps. Yeah. Okay, two-step mechanism. So guys, again, right, it's always a good practice for you to begin rate determining step. Okay, so try to identify your first step as your rate determining or second step as your rate determining. All right, guys, look at it. First step to be rate determining, which means my first step have ICL and 1 mole of H2 reacts together. Understand? Get it? One more time. 1 mole of ICL, 1 mole of H2 react together. All right, guys, go BS what you want. Go. Yeah, your time to BS now. Go. What do you guys like? Okay. Oh, HCL, okay lah. HI. Okay, good. HICL and the free radical H, right? And of course, go. Oh, you can put. Okay, so guys, after that, go and complete your second step for me. Second step, let's go. You guys do the question first. Let me mark attendance in a quick minute. Eunice is here. Eunice, Boon Xiang, Ayun, Chloe not here. Ethan, Jonas, Ding Xiang not here. Yun Fu is here. Colin, Wong Yu, Lokesh, Marcus not here. Victor, Victor Yiling is here. Anya is here, right? Anya, Ju, Arita, Yuan Xuan, Emma is here. Is Emma here? Wait, I don't see how Emma is here. Fatima is here. Is Fatima here? Fatima is here. Fatima, are you nervous, Fatima? Tomorrow exam. Yo, stress. Oh. No, it's okay, good. Alright, guys, come. Second step. What do we do next? What can we do? Okay, so I already used up one H2. I have one more ICL, right? So take out my ICL. And guys, I must get rid of my, this is my intermediate, right? I must get rid of my HI. Combine what it will be? HCl plus I2. Is that right? Guys, when you try to add up, you see, right? ICL cut out. And HI cut out, right? Wait. Is HI cut out only, right? So your final answer is gonna be 2ICL plus H2, 2HCl plus I2, right? Azan, not bad, doable? Cat? Alright, guys. Now I'm gonna give you something challenging. I'm not gonna give you any of the step. 3-step mechanism, go. Let's propose. Okay, yeah, bullshit 3-step for me. Yeah, go and BS 3-step. Again, it's quite fun. Yeah, because your answer can literally be anything. So guys, if you really want me to check your answer, you can send it in here. Because I'm not so sure. Okay, yeah, you don't just try not to copy my answer. I want you guys to be creative with your own answer. I like the voice really talking about you. Mulai dah. Tadi engineering, medical, pharmacy. School pharmacy is damn good. Yeah, I mean like school pharmacy is like second in the world, right? That's crazy. The third one. Sorry? Parkview. He's not Clayton, Shit. Damn huge, bro. I've never been to Parkview though. There's another one. That's Parkview, man. Oh, good, what is it? I remember there's another one. Yeah. Wait. Let's go 3-step. Just whack the nails. Go throw your 3-step. Sorry. Can get drink. Of course, if you next you come in physical or not? You sure? Of course, your farewell already, boy. Next week, yeah, will be your farewell, right? Hey, next week, A2 October, November, kid farewell, eh. Oh my god, hi. You know what comes next after October, November farewell? Double class for you guys. Yeah, because their slot is empty already, then I can double class for you guys. Good. Nine seven oh one. Yeah, good answer. Let's go, come. Impress me. Okay, first one. What do we have? ICL plus H2. Go, go, go. I'm ready. HICl plus H free radical. Okay. Okay, then second. HICl plus H free radical. H2 Cl. Okay. Okay, last one. H2I plus Cl plus ICl. 2HCl plus I2. Yeah, I mean, guys, yeah. Yes, happy. This answer is correct. Yeah, again, it does look super wrong, right? But in exam, if you do it that way, it's correct. But in exam, right, usually they will give you a condition. Okay, so later I will give you guys okay, some questions require some conditioning. Okay, some conditioning. All right, guys, next. All right, kid, I want you guys to look at page 15. Again, guys, for this part, right, again, I want a 2-step first, and I want 3-step. Let's go. Try this. Again, N2O5, it's my rate determining step, yeah. All right, guys, this time, right, I'm going to give you a conditioning already. I'm going to give you a condition. So my condition is, okay, my condition, guys, okay, the first condition is only maximum, yeah. Okay, 2 molecules will react in each step. So guys, again, so in exam, right, sometimes it will give you some condition. 2 molecules will react in each step. Okay, I cannot have 3%. I just want 2 molecule at max. Yeah, correct. We do. Okay, and guys, no formation of free radical. Okay, that is my condition. Go try and do it. So guys, again, no formation of free radical. Maximum of 2 molecules in each step. Okay, minimum 1, maximum 2. And no formation of free radical. Ooh. Two step done. All right, guys, give me two step. How's your two step reaction? So my first step is N2O5 turns into N2O2 and O3. No formation of free radical.
No,
Just O. Oh, O3. No, okay. O3. Can. Okay, ozone is formed. Can. Formation of ozone. Let's go. Alright. Alright, guys, after that. Okay. Maximum two molecules react in each step. Oh, so you have to conclude everything in two steps. So that can be a three-step answer. Yeah, but okay, I'm gonna move it, show it to three-step answer, but two-step. Let's propose again. Any other answer? N2O5, I can turn into can I write it as N2NO2 plus how much? What else do you need? N3. Can write. Okay, I can write it as NO2 and NO3, right? Okay, so second step. Okay, NO3. Oh, still cannot because it will be a more than. Yes, correct. Yeah. So, which means right, it must be just one. Okay, so I might get N2O3 plus O2. Okay, so if I put N2O3 plus O2, second step, I can get rid of my N2O3 with another molecule of N2O5. Immediately, 4NO2. Done. Okay, so this is a two-step reaction, yeah. You can see, right, guys? Two-step reaction. Okay, N2O3, N2O3 cut. 2N2O5, NO2O2. Okay, so that's a good one for two steps. Okay, guys, three steps. Let's go. Yeah, let's continue. N2O5, then N2O2 plus O2. After that, oh, by the way, this is my rate determining step. This is also my rate determining step. Okay, N2O2 plus O3 turn into what I tell you. Yeah, so it cannot be the same thing. So creative. Either you get creative. Yeah, you can get creative. I mean, you can still get it right. Yeah, you can still get it right. Trust me. Yeah, you can still get this right. Okay, so maybe right, I can say that it turns into okay. So O3, O2, right? I know I need to get one of the product. Either I get one of the product as O2 or one of the product as NO2. I think O2 is easier. I just get rid of the O2 first. So which means left behind is the N2O3, right? All right. That one is the same as N2O3 plus. Then yeah, you can still get it right. You see, you just have to try to BS until you make your answer correct. That's it. That's the only thing. Okay, but sometimes I really you have caught one. Why can't you do NO? Why can't we do NO2 to and NO3? Oh, why can't we do NO2 and NO3 here? If I do NO2 and NO3 here, the second step will be NO2, NO3, and another N2O, N2O5. And my condition is maximum 2 molecules of reactant. Sometimes they might just give you a condition. Okay, you have to follow. I understand. Okay. Alright, guys, now this okay, this is the final one before we move on to an example. Guys, do you remember your nucleophilic substitution SF1, S2, first order, second order, right? So what do you mean by second order, right? First order means in the rate equation, right? Okay, so guys, let's look at the first order reaction. You see, guys, okay, so this is my questions. So what do I have? My first step, right? Okay, I have a CBr connected to a CH3, connected to a CH3, connected to a CH3, correct? So the mechanism is, right, first step, this will break. Am I right? That's what you can propose. I can propose this three thingy with a positive charge, right? And Br a negative, right? Alright, guys. Let's say, right, this is my rate determining step, yeah? My RDS is here. Alright, guys, second step. Can you combine it? Get me the final answer. Where's your intermediate? My second step, my intermediate, right? I have to get rid of the intermediate, right? And what do I? OH minus, right? The product. Done. So guys, you see, right? If you do this way, do you see that this two will get cut out? And this is your final equation. Alright. Okay, so that is your SN1 mechanism, right? So again, SN1 mechanism, why is it SN1? Because in your rate determining step, right, there's only one mole of a reactant. So my rate determining step, right, is just R as to K, CH3, 3Cr, that's it. Okay, so this is why we press SN1, because only one mole of your reactant, it's limiting the rate. That. Okay, so we call it as a first order with respect to your halogenal alkane and zero order with respect to your hydroxide ion. Alright, let's try one of the toughest question that I've seen here. Okay, so next page, let's try the question. One of the toughest for, okay, so one of the toughest mechanism. The other mechanism, right, basically you BS anyway you want. But the next question, right, you can't really BS so much. Yeah. They give you some condition to follow. Next page. Let's look at this question together. Okay, you see, right? They say in aqueous solution, iron 3 ions react with iodide ions as shown. Okay, first part, initial rate with respect to Fe3 plus, second order with respect to I minus. Alright, guys, can you write down the rate equation first? What's my rate equation? First order with respect to Fe3 plus, right? Then second order with respect to, right? Oh, okay, yeah. Alright, guys, next. Mechanism, 3-step. Highlight the word. Involve only two ions reacting together. Okay, so just now I trained you guys for 2 modules. Right now, 2 ions. Guys, think about it, yeah. First thing is, and they mentioned 2 ions, right? Try to avoid this. So avoid positive and positive. Because guys, same ions with same charges, like charges, ion will always repel. Understand? Okay, so avoid positive and negative. So avoid cation ion react with a cation ion or anion react with an anion. Because I can say that it's not right. Because cation ion and cation ion saying they will repel one another. So what I'm looking for, right, is cation ion and anion together, yeah. Go. 3 steps. You must get this answer. This is hard. You know why this is good question? Because a lot of seniors they can't do it. Okay, so guys, Each and every step, I want one guy and I want one girl, yeah? Okay? I cannot have more. And next, when you combine, you must get this equation. And next, the rate must follow this. RDS must have this, yeah? This is hard. This is difficult. Let's go. So if you have any guys, this one, right? I won't show you the answer. I want you guys to send me the answer. Send me the answer, please. So I can discuss. I told you. It's your ad for everyone. All right, guys, again, some answer, right? Show me first, yeah, because I want you guys to get me some answer. Okay, that only guys, because if I give you the answer, right, then you guys won't think, yeah. So try some answer, get it and send to me. How's it? Yeah, so see, this one is still for you. So, if any of you guys done, send it to me, please. If I give you the final answer, then not fun. Sorry, Tista funnel. That Tista funnel, right? It for example, if you look at some reaction that produces gas, like so usually before you have a reaction, you have to count the reaction. It's too late for you to put stopper because by the time you put stopper, it's just yes. So how we can use this problem? You put the fire. So this definitely is attached. So you can look at so when put this one, what is it? And then you guess what the this because let's say you get also to a small testing fields, how you actually shape the double, it actually to experience or we use this level. So this level is the purpose is to be experiences. How fun, right? Now I wait for you. I don't like it. I wait for people that you. It's okay, guys. I just want some answer. I don't think that one's how do you look at this? I mean, well, it's kind of hard to do. Just that you can make people at one month. Yeah, more, but it has to be faster than the rest. Yeah, you have to balance the type. Okay, so thank you so much. All right, guys. Now, okay, you see, like most of you guys are stuck here, and the common. Let's talk about common mistake first. Yeah, guys, the common mistake, right, is you guys will do last. Okay, you guys will do this Fe3 plus and I minus two, right? Then, guys, you guys might do something like that. Fe3 plus 2I minus equal to 8. Okay, guys, this question is tricky, right? Because 95% of my students do this and immediately they get zero. Because if the first step is wrong, everything is wrong. Okay, why? Guys, underline this word. Two ions. Talking about two ions. What, how many ions you have? One, two, three. Three ions already die. So your rate determining cannot be the first one. Because if it is the first one, so it's not one and two. Okay, so guys, if you do it like that wrong already, why? You see three more already. One plus two, three. Cannot. So guys, what you can do, try to minimize it. One plus, one minus. Okay, correct. So guys, start with this. Okay, I'm gonna give you the start. Start with this. One plus, one minus, go. Okay. This time two. I think this two is definitely correct. You see, guys, one. Okay, two ions. Okay. Okay. So some kid one Fei two plus. Can everything is okay. So charges. Okay, guys, remember charges matter. Yeah, remember balance the charge. Okay, guys, this is my intermediate, right? This I have to get it. So let's put my Fei two plus here. And guys, next, let's look at it. They say, right, my determining step, it's I minus. Okay, so basically, I still need one of I minus. So I put one I minus here. Okay, guys, what it will turn into? Fe 3 plus 2. Hey, 3 plus. I think just Fe plus, right? Right, to balance it, should be F plus I2, yeah. Okay, so guys, if you do this way, let's check. So guys, this entire thing, right, Fei2, yeah, is basically representing Fe3 plus and I minus. Am I right? So basically, you have Fe3 plus and I2I minus here. So that matches your rate equation. So your rate determining step is our second step. Understand? Okay, this is the tricky part. Because you see, although your rate determining step has two more of I minus, but you look at your second step only has one more of I minus. Why? Because this one does have one more of I minus and one more of Fe3 plus. Get it? Okay, so please, and this is the toughest part, yeah. But guys, from there, I mean, everything looks right. Everything looks right. See, can we BS until our last step or not? Maybe we can, maybe we can't. Okay, let's go. What we want? I want I2, right? So this is my intermediate. I'm going to get rid of my intermediate. Now what else is required? Two more of I2 already used up. What else is left? Fe3 plus. Then you have one problem. What's the problem? Two like charges ion reacting together. Oh, so which means you see, right, if I have two like charges ion together, that's not quite sexy. Okay, and you can't do it so. So again, this is wrong. So if you do it this way, right, you might only get 1 mark here, 1 mark here, so you lose 1 mark still. Okay, because your second and third is right. Okay, so guys, can you another one? So far, right, up till here, right, is correct already. You just have to get this done. Okay, go, propose. Think about it. So guys, okay, let's try. Okay, let me show you how to do it. So I know that, right, by Fe3 plus, see, right, by Fe3 plus, do some, wow, right, I minus no more already, correct? Which means the last step here, I must have one Fe3 plus here, correct? And the intermediate species must be an anion. Which means, right, this, you must get an anion here. Understand? So guys, try to get an anion and throw it over. Yeah. Sorry? 2I minus. Okay? So guys, let's see. If you mention 2I minus, okay, and bring over 2I minus, right? What it will be? Yes, 3. That was the same problem. Hard, right? This question is hard, right? Yeah, no, cannot. Okay, let's try I2 minus. Again, guys, you get BS. Okay, mechanism is when you BS. When the molecule doesn't make sense to you, doesn't mean it's wrong. Understand? As the mechanism is right, that's what it matters. Molecule looks funny, looks weird. How much? Fe 2 plus, right? Is that right? So guys, now Fe2 plus, Fe2 plus. Okay, so that is my product. Don't get rid of it. Yeah, I know that I2 minus is my intermediate, right? Put my I2 minus here. Looks quite right though. Is it? It does make sense to you, right? You see that Fe3 plus, I2 minus, positive ion, negative ion, what it turns into? Fe2 plus, I2. Wow. You see? So guys, let's try FeI2 minus, nonsense cut out. Nonsense cut out. 2 Fe3 plus, 2I minus, 2 Fe2 plus, I2. Okay, right? Yeah, that's your answer. You see, guys, okay, this type of question, it's you have to be very, very careful. Read the question because the hardest question, right? It's question with condition. Condition one, condition two. Okay, usually you will get two conditions. Okay, guys, then in between, right? Whatsoever nonsense that you get, right? It's okay. By right, I2 has no charge, right? Then you put a charge there, it's okay. Because it's an intermediate. It's not supposed to be there. That's why you get rid of it. I said it's okay. Intermediate can be anything, can be nonsense. You BS. Please BS. But when you BS, follow the condition. That's the only thing. Okay, can. Okay, so this is the hardest one. Go and erase it. Do it yourself. See you can do it or not. Because so far, I think this question is one of the tricky one. All right, guys. Last one. Last one. Let's try this. Page 18. Page 18, part 2. Okay, I get you the rate equation already, guys. That's your rate equation, guys. And later the junior coming over for extra classes. They sitting for AS exam. I was stressing them, I was like, oh, you look at the senior did so well. Like, you guys actually, to be honest, you know that you guys did actually quite okay. I checked back, right? The average is pretty okay. But right now I'm looking at the junior, right? Oh, the junior very GG. I'm very worried for the junior. So guys, I would say this question is relatively easier. And the equation is here. Oh, sorry, I forgot to paste. I forgot to attach the equation. Hey guys, the equation is here. Again, they never, you are only dealing with one condition. Just one condition. The condition is just rate equation. It's easy. You can BS anything. And 2-step, not 3-step. Okay, so go BS. This shouldn't be a problem. As long as you get your rate determining step right, then should be correct already. Can free radical. Go, get do free radical. Okay, go. F2, okay. Okay, let's go, guys. Okay, I have ClO2 plus F2, right? You guys like F2 so much, okay, I give you F2. F2. What? ClO, okay, lah. Yeah. Chlorate, yeah, by right, chlorate should be a ClO minus. But again, this time, again, what is intermediate species can be nonsense. You don't have to put your negative there. If you want, can F2O plus. All right, guys, again, if you want to put a negative, F2 must be a plus. Don't put a negative without a charge. If you do it like that, right, it's wrong. Charges not balanced. Okay? Okay, so guys, I'm going to make it more complicated. F2O plus, Cl minus, ClO minus. All right, then second, F2O plus, ClO minus, plus another molecule, ClO2. Boom, everything turns to a ClO2F. Yes.
For the charge gain, I put as long as it's balanced.
Yeah. You want it
like
O plus.
Four plus.
Let me tell you, your E levels, right, is already quite nice. They give you 2 steps. You know IBDP chemistry, they have 7 steps. You know how 7 steps gonna look like? ClO2 plus F2, right? You can create your own element A plus. Yeah, A plus. Then A plus B minus, C2 minus. That is IBDP. I'm not kidding. IBDP can have 7 steps. Yeah, and it's crazy. Like suddenly out of sudden, right? A hypothetical element come out. Cl plus F turn into GHO. Yeah, it's something like that. Yeah, I'm not kidding. IBDP chemistry. Yeah, IBDP. Even OPS. IBDP BS 7 step, bro. Yeah, so you guys are quite nice already. So usually, right, in exam, they might just ask you for 3-step BS. Okay, so more than 3-step BS, I mean, you guys still be able to do it. Okay, good. Hey guys, that will be all for the class today. Sorry, I'm late today. I'll try to extend the class next week, but for October, November, later we have another round of extra. I'll see you guys later. Okay, 9 to 10. Yeah. Yeah, you go home, rest first. We're just gonna quickly go through some P5. Just a quick recap. I don't want you guys to sleep too late also. Right now, the junior is coming in. Junior, show them the BS. Scared them for A2 junior.
Mr. Chin.
Hi, junior. How are you? Yes, Harita, you were saying something?
My question.
Please like and subscribe. Show someone active. Please like and subscribe.